Okay, so we're going to just look in more detail at the solutions to question 9, 13, 15 and 19 for anyone who had any trouble with them, and they're from the questions on page 64, 65. Okay. Okay, so we'll go through this question first. So the first thing we're told, this is the Venn diagram below shows the number of elements in each subset, etc. And so the first thing that we notice about the set S is it's missing a box, so it's a rectangular box around it. And then so we need to write down, so hashtag S somewhere there. I'll just zoom in on this maybe for a second. So hashtag again being the number of elements in S, and it's so that's the cardinal number of S, and well, it's 7 and 3 is 10 and 2 is 12 and 8 is equal to 20. So that's the total number of elements in S. Okay, and so once we have that, then it's straightforward enough from there. So all of so part 1 is write down the probability that the element will be in the set A. Okay, so sorry, 1 there, and so it's P of A. Well, how many elements are in A? So it's all of A is 7 plus 3, which is 10, out of the whole set, which is 20. So it's 1 over 2, which is a half, or 0.5. Okay, next question then is probability of B. So again, we can see, well, B is all of this. So it's 2 plus 3, which is 5 over 20, which is a quarter. So that's part 2. Part 3 is the intersection. So P of A intersection B, well, we can see the intersection, this bit here in the middle, is equal to 3, and it's out of 20. Next part then is part 4, and it's the probability of A union B. So it's anything in A or in B. So it's 7 plus 3 plus 2, which is 12 out of 20, which is equal to 3/5. Part 5 asks us the probability of A without B. Well, A without B is just this part here lacking the intersection, so that's going to be equal to 7, and it's out of the whole, which is 20. And then here we're asked in part 6 for the probability of A without B union B without A. And we'll just put all of that into another bracket. So that's going to be equal to, so well, we had just gotten the probability of A without B to be 7 over 20. And union always means to add, so we'll add in that. And B without A, well, we can see that, that's this bit here. So that's 2 out of 20. So that answer then is a total of 9 out of 20. Okay, and then the next part, part VII, we're asked the probability of A complement, or which means again anything that is not in A. Well, what's not in A? This bit here and this bit here. So it's equal to 2 out of 20 plus 8 out of 20, which is 10 out of 20, or a half. And then lastly, on this part, we have the probability of A union B complement. Well, we can see A union B is 7 plus 3 plus 2, which is 12 out of 20, or everything that's not in those is the bit that's here in outer space. So that's 8 out of 20. And then just simplifying that, that is 2/5. Okay, so that's the first section done. And then for part B, let's have a look at those. Okay, and so in part B, the first part, we're here asked to verify that the probability of A without B is equal to the probability of A minus the probability of A intersection B? Well, over here we got the probability of A without B to be 7 over 20. So we've 7 over 20. We also have the probability of A is a half. We'll just put it back as 10 over 20 for the simplicity of this. And the intersection is minus 3 over 20. So 7 over 20 is equal to, well, 10 over 20 minus 3 over 20 is indeed 7 over 20. And that is true. So we have verified that that's the case. And basically it is, I mean, we know just even from reading this again, the probability of A without B, this bit here, is equal to all of A minus this bit here, which we can see very clearly. Okay, and then the last part. Okay, so here in part 2, we're asked to verify that the probability of A union B, so A or B, is equal to the probability of A plus the probability of B minus the intersection. And the reason for that is if I've counted all of A and all of B, I've counted this twice, so I need to remove it. So let's just verify that. So, well, we have over here again probability of A union B. Again, we'll keep it over 20. So it's 12 over 20 is equal to the probability of A, which was 10 over 20, plus the probability of B, which was 5 over 20, and the intersection is minus 3 over 20. So 12 over 20, well, that is equal to 10 plus 5 is 15, minus 3, which is 12 over 20, and that is true, so we have verified that. Okay, so that's question 9. Okay, so before we start question 13, or as we started, it says, a pair of fair 6-sided dice is rolled. Find the probability that the total on the pair of dice is whatever. So basically they're rolling 2 dice, they're adding the scores together. So let's draw a two-way table to reflect that before we attempt any of the questions. Okay, and so very simply filling in our table then, will we get, so 1 plus 1 here in this first position is going to give us 2, and the whole way across 3, 4, 5, 6, 7, and the same. 2 plus 1 is 3, 5, 6, 7, 8, and we fill in so on just like that. Okay, so now that we have our table, we can see we want to find out, so the probability that the event is equal to 4. So, well, how many 4s do we have here? We have 1, 2, 3, so it's 3 out of, and how many have we got in total? 2, 4, 6 times 2, 4, 6, which is 36 possibilities. So 3 out of 36 is our answer there, which when we simplify that down is 1/12. Okay, so and continuing on, part 2, we have probability that it's 4 or less, so less than or equal to 4. Well, we can see from our table up here, we have 1, 2, 3, 4, 5, 6 that fit that description. So that's 6 out of 36, which is equal to 1/6. Part 3 is greater than 9, so probability greater than 9 is equal to, again, so we're looking for 10, 11 or 12, and we've 1, 2, 3, 4, 5, 6. So that's 6 out of 36 again, which is 1/6. Okay, next part, an even number. So we've P of even. So how many even numbers have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, and count them up, and we have 18 even numbers out of the 36, which is a half. Okay, next number, part 5. So we have probability that it's less than 6. So P less than 6, or, so we know that or is always the union sign, or prime. Okay. And well, before we even start that, we know that union sign always means to add here. Okay. So we'll be adding. So that's going to mean that it's equal to probability of being less than 6 plus the probability of prime minus the intersection of less than 6 intersection prime. So like we said before, we're not double counting. Anyways, that's it written out, but otherwise we can just count up here. So, well, what's a prime number? And so less than 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then adding on our other prime numbers then as well that are more than 6, we have the 7s. So that's 11, 12, 13, 14, 15, 16. And then other prime numbers still 17, 18, 11. So that's it. So it's 18 out of 36 is our answer, which is a half. But obviously we could have done it in those bits there and just made sure that we weren't double counting the ones that were less than 6 and prime. Okay, so that's part 5 sorted. So part 6 is exactly twice as great as other possible totals. Okay, so we'll do this a little bit differently. So what options are we looking at? Well, 4 is equal to 2 times 2. 6 is equal to 2 times 3. 8 is equal to 2 times 4. And 10 is equal to 2 times 5. And 2, 3, 4, 5. And we go up as far as 12. And 12 is equal to 2 times 6. So now we're looking, how many times does a 4 occur? So it occurs 3 times out of 36. So that's equal to 3 out of 36. 6 comes 5 times, I think. 1, 2, 3, 4, 5 times out of 36. 8 happens, again, we'll just count that up. 1, 2, 3, 4, 5 times out of 36. 10 we can see happens 3 times, 3 out of 36, and 12 happens once out of 36. And so we'll add all those together, which gives us 17 out of 36. So that's our answer in there. Okay, and then our last part is that it is 10 or less. So probability that it is less than or equal to 10. Well, that's the same as it's 1 minus the probability that it's greater than 10, which obviously just is a quicker way for us to do it here because there's less numbers that are greater than 10. So that's 1 minus, and so the numbers greater than 10 are 1, 2, 3. So that's 1 minus 3 out of 36, which gives us 33 out of 36, which is 11 over 12. Okay, so that's question 13. Okay, so here in question 15, we have a fair-sided, 6-sided die is rolled and an unbiased coin is flipped, and so represent the sample space in a two-way table, so much the same as we did in the last question. So here we go. Okay, so we've heads and tails there, and then our numbers on our die, 1, 2, 3, 4, 5, and 6. Okay, and so our die is rolled first, so that's what we will write down first into the table. So we're going to have our 1, 2, 3 in this area, 4, 5, and 6, and the same down here, 1, 2, 3, 4, 5, and 6, and then that's 1H, 2H, 3H, and so on. Here will be 1T, 2T, etc. Okay, so that's our table finished, and we can put that up there, and then we'll use it to answer the question. So question 1 is the probability of a 5 followed by a head, so probability of 5H. So it happens once, and the total number of possibilities is 2 by 6 or 12, or you would count up the boxes here in the two-way table. Okay, the next one is probability a prime number followed by a tail. So that's P of prime comma T. So how many instances do that occur? Well, 2 is a prime, 3 is a prime, and 5 is a prime. So we have 3 out of 12, which is a quarter. And then the last one, probability in question 3 is an even number. So P even with a head or So that's going to be an intersection, head, and then or means union, odd, so odd, width, so that's intersection again, tail. Okay, so that's it written maths wise. So let's just work that one out. So our quickest way now will just be literally to take that from the table. So even and heads we have 1, 2, 3 out of 12. And or the union we know always means and to plus them. And here then odd and tails we have 1, 2, 3 out of 12. So 3 out of 12 plus 3 out of 12 is 6 out of 12, which is a half. Okay, so that's question 15. We'll look now at question 19. Okay, so in question 19 we're told a fair 6-sided die is rolled 3 times, and then we're asked what's the number of elements in the sample space. Well, just to go back to this previous question that we did where we had a die rolled twice, well, what did that give us? It gave us 6 by 6, which was 36 possibilities here. So if it's rolled 3 times, well, then that means in part 1 we're going to have so 6 by 6 by 6, or 6 cubed, which is 216 elements. Okay, and I'll just get rid of this so that it's not confusing us. It was just as a help, as a reminder. Okay, now so that's part 1. Part 2, it says what's the probability that 3 6s appear? Well, that's only going to happen once. So probability of 6, 6, 6, which is once out of 216. The next question says, what's the probability that the first roll yields a 6? So we've probability of 6, and that the sum on all 3 rolls is 14. Okay, so we need to write down what are the different possibilities that make that up. Okay, so we'll go, well, if I have 6 and I add 6 to it in the next one, well then 2. So those 3 altogether give me, actually I'll just list all the possibilities rather than writing it out in a big way there. So hold on. So the first one is going to be 662 is one option. So we know they all start with 6. So we have 6, 5, 3. We have 6, 4, 4. We have 6, 3, 5. We have 6 and 2 is 8. And another 6 gives us 14. And we can't have 6, 1 and 7 because obviously there's no 7 on a die. So that's the list of those possibilities. And is there any others that we could add on? We could have, okay, so they're the full possibilities there. There's no more. So how many have we of that? So that's going to give us a total of 5 possibilities out of 216. Okay, so that's part 1, 2, 3. Okay. Okay, and then part 4 then asks us what is the probability that the first roll is an even number and that the sum on all 3 rolls is 14. So similar again, well, we've all those possibilities from up above. So we've the 6, 6, 2, 6, 5, 3, 6, 4, 4, 6, 3, 5, and 6, 2, 6. So there, obviously, beginning with a 6 is an even number. So what else could we begin with? We could begin with a 4. So we could have 4, 4, 6, 4, 6, 4, 4, 5, 5, and that's all of the 4s. And then the other possibility for an even number is to begin with a 2, and so 2 could be 2, 6, 6, And that's the only possibility there that we haven't already encountered. So adding all of those together, that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 216. And if we break that down or on our calculator, that's 1/24. Okay, so that is our answer to part 4. Okay,